today, I would like to talk about the fundamental of Wheatstone bridge. As we have here is the schematic diagram for the Wheatstone bridge. Okay, this Wheatstone bridge circuit is mainly used for measuring electrical resistance. So the circuits of the Wheatstone bridge is built in the form of bridge using three known resistors, which is the R1, R2 and R3, and one unknown resistor, which is the Rx. By using this bridge, we can find the unknown resistance very precisely by comparing it with the known value of resistance. For this bridge to be in balance, the condition voltage at point C must be equal to D. So if the voltage value is equal, then there will be no current flows through the galvanometer. For getting the balance condition, one of the resistor must be variable. Using the Wheatstone bridge, LDR, operational amplifier and some standard resistor, a circuit can be constructed to output a high or low level signal which is dependent on a selected threshold. An LED will be used to determine the state of the system. So in the practice, the Wheatstone bridge is seldom used merely to determine the value of a resistor. So I will pass on to Akashah in explaining about our project.
This is the schematic diagram for our project. This project is we use the application of Wheatstone bridge circuit with the IR proximity sensor that use transmitter and receiver photodiode on the circuit. In this circuit, we use power supply from the power bank, the transmitter photodiode, receiver photodiode, the potentiometer, amplifier, and the resistor that we use. We have 100, 10K, and 220 resistor. We also have the output component, which is buzzer and LED. This is how our project works. I will explain the working principle of IR proximity sensor. First of all, we need two components, which is IR LED and photodiode. So this component I will explain each one by one. First, IR LED is used in this circuit to transmit infrared light. An infrared light emitting diode LED is a type of electronic device that emits infrared light not visible to the naked eye. Then, the photodiode is used to capture infrared reflect light of IR LED. This component is a semiconductor diode that, when exposed to light, generates a potential difference or change its electrical resistance. This both sensor module works on the principle of reflection of infrared rays from the incident surface. A continuous beam of IR rays is emitted by the IR LED whenever a reflecting surface, white or obstacle, comes in front of the receiver photodiode. Then these rays are reflect back and capture whenever absorbing surface, black or no obstacle, come in front of the receiver. These rays are absorbed the surface and thus unable to capture.
Move on to result and analysis. So we have carried out an experiment to test the IR proximity sensor in detecting an object from a distance by adjusting the variable resistor from high to low value. So now we reduce the resistance into the lowest value So let's see the result. This is the highest resistance value that we have set on the potential meter. So let's see the result. From the experiment, we can conclude that as the resistor value increases, the distance of the IR sensor to detect the object will decrease. So we'll move on with the discussion. I would like to discuss about the problems that we faced during the process of constructing our project. So for the first problems that we faced is bad connection. These problems occur when there is a short after we solder the components together. This makes the circuits to be incomplete and malfunction. So by double checking the solder joints, we manage to overcome the problems. Second is the LED burns out. Our LED burns out because of the excessive current flow from the power source, which is 9 volt. So in order to overcome the problem, we reduce the power supply to 5 volt. Then finally, the problem that we face is wrong connection. We failed to identify the positive and negative terminal of the components, which caused the circuit to be incomplete and not function.
The application of proximity sensor first of all, to detect the dynamic motion in the factory line. Most of the factory use proximity sensor to detect the motion on the line and as a counter. Next is at the car parking sensor, mostly used at the bumper of the car to detect the front and rear car bumper. Next is used on mobile phone sensor. As an example, used on the screen when the ear of person near or touch the screen will become dark to decrease the use of the power supply.
As for the conclusion, we learn on how the principle of the Wheatstone bridge is applied in a circuit, and then we also gain knowledge on the further application of the proximity sensors that are used on most of major industries.